Hello everyone, it's Paul with TutorU, and today we're going to be going over slope and the rise and run of lines. There are a lot of things to know about about slope. A lot of people struggle with the concepts of it, right, and like getting it down in your head. But I promise after today's class, watch it all the way through. I might make a couple of mistakes here and there, but I promise you it's going to help you net, right? Like overall, it's going to help you understand the topic of slope. Let's just get started on this. As you can see, I have my whole little rise and run and a little graph drawn up, but let's kind of go in and kind of define what slope is, the word definition of slope. So we will clear this off as soon as I can find my cursor. Boop, there it is. So let's talk a little bit more about slope, and boom, I made everything disappear. So let's define slope. What is it? And I'm just gonna write this out. It is the steepness of a line, Okay, and yesterday we were covering the grid system. I talked a little bit about the coordinates, the ordered pairs, right? So you have ordered pairs, you have your x and your y axis. Let's go ahead and put that on the graph the best that I can. It looks a little bit wonky, but it'll do. It will do. That'll do, pig, that'll do. Okay, so if you remember from yesterday, our vertical line is our y, and our horizontal line is the x. So this is the x-axis and the y-axis. Okay. Your y-axis covers your vertical points on the grid system. Your x-axis covers the horizontal points on your grid system. And if you remember, what is the origin? The origin is the point 0, 0, and it is right in the middle, okay? Our origin is in the middle. Always remember that. Your starting point is always 0, 0, right? And so if we were to label this grid, we would have 1, 2, 3, and this right here would be point 4. And then to the left would be the -1, -2, -3, and -4. Same exact concept with your vertical, your y-axis. That would be positive above and negative below. -3, -4 down there. There. So we have our labeled grid system. Everything looks pretty good. Steepness of a line, right? So what I want you to think about is like a mountain, right? It is very steep. Some of the mountains can be extremely steep. And when you think of a steep mountain, usually they tend to be taller mountains, right? And so your slope increases, right? That steepness of the line increases the more vertical the line is. Okay? So the slope, the closer you get to vertical, the higher that slope is, right? Let's clear that off. Let's talk a little bit about that rise over run, okay? Hang on. So your rise, so what is rise, and why do I keep saying rise over run? So rise is the vertical change from one point to another. So vertical change from one point to another. Oof, my handwriting is nasty this morning. Let me change to a pencil instead of the pen. From, that doesn't work. There we go. From one point to another. Okay? So from one, that still looks so gross. Hang on. I need to rewrite that. We'll go with a sharp pencil from... Hey, that looks a little bit better. One point to another on a line. So what does that mean? What does that look like? Okay, so we will just make up a graph, okay? I'm just going to draw 2 points on a line. We will figure out the slope of it. So my first point, if you remember ordered pairs, so my first point is this one in the top right of the screen, and that is point, so that's 4, 1, 2, 3, 4 over on the x-axis. And how many up? 1, 2, 3 up. So that is the point 4, 3. That is the ordered pair. Okay? Let's change this one more time. We'll try this felt tip pen out. Then, our second point for this line, let's go down here. So my second point, labeling that one, we have -2 and -2 for our second point. And let's write that over here. So -2, -2. And since I'm saying this is a line, there's going to be a straight line that connects these two. And look at that. I drew that A-OK for freehand. That looks straight enough. And always draw your arrows out, because that means that it goes on for infinity. And if you remember, your line, it's all of the possible solutions to an equation. That is what the line describes, right? So every single point, so for whatever equation this line is, the point 4, 3 will answer the problem, and the point -2, -2 will answer the equation. But what if I just asked you what the slope is, right? So let's erase a little bit of this. So we will get rid of our definitions. Wait, I can make that eraser a little bit bigger. So I give you these 2 points of the line, and I ask you to find the slope of this line. The way that you go about doing that, we'll use this nice blue to give it a little bit of difference, is one of your first ways is to find the rise and run, the change in the vertical over the change in the horizontal. So we will finding the slope. Okay, so we're going to find the slope a few different ways. The first one is just graphically, right? We have this graph, and we can just figure it out without having to do too much. And I will write down, and I would highly recommend that you write down, slope is equal to rise over run. Okay, so rise over run, what am I talking about with rise over run? So the rise is that change in vertical. So from this point down here, how much did it change vertically from this point here? So what I'm going to do is, so it moves up, right? From left to right, it's moving up. The graph is moving up. So we are going to count. So here's my horizontal line. We don't want to count that yet. And then my vertical line. Okay, so how many points up is this? So we'll go a little bit darker. That is 1, 2, 3, 4, 5. We changed 5 points in the vertical, right? So we changed 5 points in the vertical. So our top number is 5 over, and then what is the change in my horizontal, my run? So the change in my horizontal is 1, 2, 3, 4, 5, 6. 6. So my slope equals the rise over the run. So the slope of this line is 5/6. Okay. You might be asking, well, Paul, where am I going to use this, right? Where might I use this? Well, let me introduce an equation. And this is a very important equation to have down. It is your slope intercept form of an equation. Oh. Slope intercept form. What is slope intercept form? That is, it's a lot of letters. I apologize ahead of time for all of the letters you're about to see right here. And that is y equals mx plus b. Okay, so y equals mx plus b. That is slope intercept form of an equation. If you can recognize some of the things in your equation. That would be the y and the x, right? Well, what is the m? What is the b? So we will write m equals the slope, and b, I'll put it right there, right here. So is b equals the y intercept. It's a long word. There we go. Intercept. It looks okay. So your slope intercept form is y equals mx plus b. The m in y equals mx plus b is your slope. Your b is your y intercept. Okay? So let's just say we could rewrite this. Well, not rewrite it, but we will erase all of these things. So let's erase all of this. Okay. We're going to keep that slope because I'm going to use that. I'm going to use that in that y equals mx plus b equation. So if we were to rewrite it as y equals, and then the m was our slope, right? So we put that where the m was. So we put the 5/6 where the m was, and then put your x plus b. Okay? We've already found the slope. If your question was, how do I find the slope? Graphically, it's very simple. It's just you count your movements. How many times vertically you move and how many times horizontally you move. Okay? And it's rise over run. You're changing your vertical axis over the change in your x-axis. Okay? But what if we had all of this on our test or whatever type of quiz we are taking, and then I asked you to find the y-intercept, right? I didn't give you any other information, and I'm asking you right here where it crosses the y line, right? We can make that yellow. I'm asking you this point here. My grid is not the best, but that's okay. But I'm asking you where it crosses your y-axis. So how do we go about it, right? How do we figure out our y-intercept? Well, the first thing that we do is that we've already found our slope, so we take one of the 2 points that we were given. We were given this 4, 3, and the -2, -2, okay? And you pick one of these, and you're going to plug it in to this equation right here, okay? What do I mean by plug it in? Remember, your ordered pair, we'll put a little note up top. Your ordered pair is always your x coordinate first and then your y coordinate second. And so if we pick, we'll call this point 1 and this point 2, we can pick either one of these 2 points, okay? So which one do we want to pick? I have a preference. I kind of want to just deal with this negative, let's go with -2. Ooh. Yeah, let's go with -2. Why not? The -2, -2. So what that means is that our x value equals -2 and our y value equals -2. And we're going to plug these in for that equation, okay? So we will rewrite this one more time with the -2 equals, let's go a little bit of a darker color. So -2 equals 5 over 6 times the -2. And we'll move this over. Let's move that just a little bit farther to the left. Plus b, right? So I'm trying to figure that out. We are trying to figure out what b is. That is our y-intercept, right? So b is going to be our y-intercept. Let's erase these points. We don't need them on the board anymore. And I am starved for space already. So, how do we solve this? Well, we just solve for b. We have one equation and one unknown, so it's very, very straightforward. We just multiply the 5/6 times, let's make that a little bit bigger. The 5/6 times 2. So what is 5/6 times 2? We have, how do you multiply that fraction, right? That's the big question. How do you multiply 5/6 times this -2? Don't forget the negative sign. Remember, bad things can happen if you forget the negative sign. So you multiply straight across. So what we have is -2 equals -10 on top over 6 plus b. Okay? How do we get rid of this -10/6? There's a few different ways. You can change this into a mixed number if you want to. Preferably, I don't like doing that. I don't like changing them. We will erase all of our top pieces now. We don't need this anymore. And we can move everything up. We have our slope written down. Okay. There. We have space again. Okay. So, what do we do? What's the opposite of a -10/6? It's a positive 10/6. Remember, inverse operations, you want to do the opposite of what is happening. So we are going to add 10 over 6 to both sides. Okay, we're going to add 10 over 6 to both sides of our equal sign. And this equal sign, I always like to think of it as almost like a mirror, right? Whatever happens to one side is going to happen to the other side. Okay? So what is a -2 plus 10 over 6? That's our big problem, right? So let's go ahead and add those two things together. We'll do that right here, right above my head. And maybe, just maybe, it would be wise for me to make myself a little bit smaller. Oh, look at that. I'm just a tiny little human being in the corner now. Okay. So -2 plus 10/6. I can write right here, -2 plus the positive 10 over 6 equals b. And this will be our answer for the y-intercept because y is the y-intercept, okay? So, how do we add these two? There's a couple of different ways that you can go about doing this. Preferably, my easiest way to do this, remember your bottom number has to be the same, right? So what if we, this is the shortcut way. As a teacher, I wouldn't advocate for this method all of the time, right? But let's just check it out. So how many times does 6 go into 10? It goes into it one whole time. So one whole time, and then with a remainder, let's make that a little bit, there, a little bit better. So one whole time with a remainder of 4 over 6. And what is another way of thinking of 4 over 6? that is 2/3. So let's change that to 2/3. And then -2 plus, oh, I'm right on top of it. -2 plus the 1 2/3. Okay, so what's the difference between a -2 and 1 2/3? Or we can kind of think of it like subtraction, right? But it's a 1/3 so if I asked you what's the difference between 1 2/3, what is the difference between 1 2/3 and 2? It's 1/3, right? So our answer here is going to be a -1/3, okay? Because this is that negative number. So our answer is B equals -1/3. So B equals -1/3. A little bit messy, I know, I'm sorry. But hey, oh geez, I moved the whole thing. Let's see if I can move it back all nice and cleanly. How do I do that with my pen? Oh, look at, whoa. It's a party. There we go. Nah, this is a little bit low now though. I'm still getting used to some of my technology. This takes a long time. Oh, there's a little bit of lag. Lag. That's my accent coming in. Okay, let me get this centered properly for everybody. Where did my cursor go? There, that looks okay. That doesn't look too terrible. We have our B circled. Remember to always circle your answer. So our answer is -1/3. We will erase this. If I were to rewrite this equation now, the whole equation, and we used our 2 points, we found our slope, and then so our answer would be y equals 5/6x plus, or we could just go with a -1/3. Okay, and this would be the equation. This right here is our equation that describes this red line. Okay, so this line gives us all of the answers to this equation. Pretty neat, pretty cool, very useful bit of information. All you need, 2 points. That's all you really need, and you just make the statement, or somebody makes the statement. These 2 points form a line, and so that tells you can connect those 2 points. You can then find the slope of it. You can find the y-intercept, right? You can find all of these bits of information just about that line. Okay, let's take a look at some example questions. So what if we don't have any graphing paper? There's no room to graph, and all they give us are 2 points, right? I mean, you could make a little graph for yourself, but that's not very time efficient. There is another way. There is the slope formula, okay? So I'll salvage as much as what I can, and that's not how you move it. There we go. So we have the slope, and then formula. Okay, so if you were given 2 points, you can find the slope of that line through this formula, and that is equal to slope equals, and then in the top you have y2 minus y1 parentheses all over x2. Ooh, I don't like having it. It makes it look like exponents. It's not exponents, guys. Let's erase that, and we'll put the 1 and the 2's right down here. 1 and 2, and then it's x2 minus x1, end parentheses. So this is your formula for finding the slope. Okay? Well, it's like, Paul, how do we use this then? Well, remember, we have our 2 points. We have the -2 and -2, and then we have our point 4 and 3. And so all we have to do is subtract these two. So we have our point 2 and our point 1. So let's go ahead. This in a way, this second point way up in the corner over in the top right, that is like x2, and this is y2. And up here is x1 and y1. Okay? So all we have to do is just plug and chug. Plug it into your slope formula. We're going to get the same answer, but let's just check it out. Let's test. So we have 3 minus a -2 all over, and then x2 is our 4 minus a -2. And look at that. Look at that. You just go through, you have your two negatives by each other, so you go a plus and a plus, plus and plus, and our end result, so we'll put our equal sign there still, our end result is going to be the same slope that we found earlier of 5/6. Boom, we found our slope. If that was what I was asking you, you just get that. Now that we have that down, let's go ahead, I'm going to erase everything. Everything but the formula and our grid, right? So let's go ahead. Oh, oops. Immediately erases the formula. Yeah, that would be great. Okay. Just to clean, oh, I'm gonna have to erase our grid too. That's okay. Not the lines of the grid, but our axis. So we'll have to redraw that at some point. So let's take a look. Let's do another 2 points. We have -1, 3, and 1 and -4. No, 1, 4, -1, 3. So our 2 points are going to be -1, 3. Way up there in the top, almost off of the screen. -1, 3. And our second point is going to be 1 and 4. 1, 4. These are our 2 points we're going to be working with, and I ask you, hey, whoever, find the slope of the points, the line that runs through these 2 points. So I've already told you that it forms a line, so you're good to go to use all of these different equations, right? So you just plug it in. So we will do in red, we will do our y's. And so we have 4 minus 3. So slope equals 4 minus 3 over, and in blue, we will do our x's. Oh, hold up, wait. Is this going to be okay? That's what you should always ask yourself, right? This is awfully close to being undefined, but is it? 1 minus a -1. Okay, so that -1, it saved us. How do we deal with this negative, the minus and the negative? Well, you change them both to positive. The two negatives cancel each other out. So what you get is, what's 4 minus 3? Well, that equals 1 over, and then 1 plus 1 is 2. So our slope of the line, circle your answer, always circle your answer, is +1/2. Boom, we're done. We've got it all under control. That's the slope of a line. It's not too bad, right? Let's see. What if I gave you something else? What if I gave you, instead of our let's go with a new layer, and we will dye it all white so we have room to work on. There, I got rid of everything. We are starting from blank. So what if I gave you this triangle here, and let me draw this out. Okay, and then I tell you it is some type of crazy ramp, right? So we have our triangle, And I tell you that this ramp is 32 feet long. And it is 2 feet tall. What is the slope of this ramp? Can you tell me the slope of this ramp? Absolutely. Given the stuff I gave you, don't forget the main idea. I'll put that in the top right. So slope equals rise over run. That will always be true. Rise over run. That is the slope of anything. Oh, dang. It's just a little bit off. I'm happy that I check my stream all of the time. Just so, there. Now we're good. Now we are sitting in the top right. So, we have our rise over our run. Another way of thinking of slope is your change in y over the change in x. I know I'm throwing some new symbols in. Paul, what is this little triangle? Why are you giving us this? It's just good for overall math knowledge. This triangle looking thing, it's also known as a delta, and it means change in. Change in. Change in anything. It can be change in anything, but it's the delta of something, okay? So I'm asking you the delta of the ramp, the change in the ramp, the steepness of the ramp, okay? So how do we do this? Easy peasy lemon squeezy. We do 32. So 32, that is the length of our run. So that is the bottom number. So 32 over the rise, which is 2 feet. So 2, and the change in that. So it is 2 feet over 32. So this would be, what is 2 over 32? How do you simplify 2 over 32? What's another way of writing it? I'll keep it over here on the far right side of the screen. 2 over 32 is another way of thinking of 1 over 16. Okay? There we go. That's your answer. That's your slope. Easy. Not bad. I'm not circling it in red this time, but 1 over 16 is the slope of the line. Not too shabby. I hope if anybody has any questions, don't mind asking. That is what I am doing this for, right? Just to offer a nice little alternative to anything, really. If you want to learn, oh, look it, I'm exposing my graph. That's kind of neat. It's like a magic trick. 1/16. How big is my graph? Okay, good. It's stuck. It's stuck to the size I was wanting it to. Wait, how far down does it go? Oh no, it goes all the way down. Interesting. What have I done? Huh. You know what? I know what we will do. I will change it all to white. And we will erase everything nice and easy. And look at that. I can cover everything back up. Okay. Now at this time, I'll take this moment before we move on to more example problems to ask you guys to, if you guys are liking this video and this type of content, right, this educational type of content, please hit the like button, subscribe. I do this class, I try to do it anywhere from 9 to 9:30 every day of the week, so Monday through Friday. Fridays are usually free-for-all, right? I will do any type of thing on Fridays, but otherwise I am keeping to somewhat of a structure. If it's a GED class that you're looking for, I can help you with that. That is going to be my main focus, but general knowledge of what is on the GED, right? If you just want to learn math, that's going to help you out a lot. But let's move on. Let's do another example problem. But yeah, like I said, if you hit the subscribe button, it's going to pump my channel out there to more people, right? And hey, you might help someone get the information that they need, right? And that's why I'm such a big advocate for kind of pushing it a little bit, right? So let's look at another example. Hypotenuse formula. Hey, okay, wait, I have a couple of people. I have Alpha and I have Spooky Gamer. You are wanting your hypotenuse formula. Do you know what? We will take a small minor detour of the hypotenuse to find the hypotenuse of something, right? So let's just go with let's go with our triangle. Let's see. I'm not the best at drawing. Okay. So we have our triangle here, and it's 3 and 4. I give you a triangle with the lengths 3 and 4, and I ask you to find the hypotenuse, right? How do you go about doing that? It is, you can go this way, a squared plus b squared equals c squared, right? The Pythagorean theorem, right? So that's the words that you were looking for, the hypotenuse formula. Pythagorean theorem. This is applicable to anybody, right? If you're taking the GED, if you're in high school, if you're prepping for ACTs and SATs, you 100% should be familiar with this formula, the Pythagorean theorem, a squared plus b squared equals c squared. So, how do we do this? Well, we can just say this is a. No, let's not do that. There we go, a, and this is b, and you plug it all in. So a, so 3 squared plus 4 squared equals what? Well, 3 squared is 9 plus 16 equals, well, what is 9 plus 16? That is 25. But this is c squared. C squared equals 25. Okay. I know this is not what you're coming in for with slope. We will get back to slope. C squared equals 25. What is the square root of c? And what is the square root of 25? We will get back. A little detour. I had somebody in the chat ask me about the hypotenuse formula, the Pythagorean theorem. Well, your square root and your exponent cancel out, and what you are left with is c equals, what is the square root of 25? What times what equals 25? It is 5. Okay? Nice, easy peasy, lemon squeezy type of triangle here. And actually, this is a very good triangle to know. Very good. Okay? This is a special triangle. It's called the 3-4-5 triangle. And I know you're like, Paul, I mean, come on, man. Like, you just put the sides on there and now you're saying it's special? Absolutely. They use this triangle in construction all of the time because it will always have a 90-degree angle. If you make anything in this ratio, right? If I went 6, 8 on my triangle, oh boy, I'm really getting all angled here. If I went 6 and 8, you should be able to look at this triangle and just tell me what the hypotenuse is, right? I guarantee you thousands upon thousands of construction workers right now, if we ask them what the angle between this line, this 6-foot long wall and this 8-foot long wall, and we put a wall or connection in between these two, the 8 feet, we would know that this is a 90-degree angle, and this would be 10 feet. Notice the ratio. So this is 5. So all I did was increase this ratio by 2, right? I could teach you all types of cool, fun math like that. But let's go ahead and erase all of this, and we will move on to another example problem. Okay? Not erase, Paul, come on. You have to do the whiteout. There we go. Okay. I hope that helped you out, Spooky Gamer. We have went over a little brief, quick summary of the Pythagorean theorem. That is one complex problem. I mean, we could get deep into it. We could get into some theoretical math or some more modern math. Here, just for fun, I want you to think about this. So there is that formula. There is the formula of, we'll make it a little bit smaller. Change to a felt tip pen. So we have a squared plus b squared equals c squared, right? I'm up above the monitor. Okay, so if we have our a squared plus b squared equals c squared, here is my question that I would like to propose to all of you. What if it's just a to the n plus b to the n equals c to the n? Are there any other numbers that work? Are there any other numbers that work for this? Right? Okay. And I'll give you a little hint. You can search the internet if you want. This is also known as, this is kind of the beginnings of Fermat's, I think this is how you spell his name, Fermat, or is it Fermat? Google will fix it. Fermat's last theorem. Right? The part that's so fascinating about this theorem, right? So like I want to say it was the 1700s, he made this statement in the corner of one of his books he was writing. He made this statement that no, only 2 works. None of the other numbers work for Fermat's last theorem. And he just said, I've proven it, but I don't feel like writing it all out here. And so you're just like, well, what the heck, man? You just made this bold statement in mathematics to say that only one number works. There's an infinite number of numbers. But to make this bold statement and say that only 2 works in Pythagorean theorem is quite bold, quite brave of you, mister. So, he just said, I proved it, but I don't feel like writing it all out. It's somewhere. It was never found. Nobody found his proof of this statement, right? Of that statement. And it took hundreds of years. We didn't prove Fermat's last theorem to be true until like the 1900s, until like 1980s, I want to say it's like 1996 we didn't finish this, right? Math is awesome. If you ever want to check out something pretty interesting, go ahead and check out the math problems of the century. Every 100 years, math is such a big, huge, massive undertaking by the human population. Every 100 years they release a group of math problems, and if you solve them, you win tons of money, you win notoriety, you get all types of cool things, and like that's just what math is, right? Like it's super neat actually. It's very, very exciting. So like in the year 2000, let me make myself a little bit bigger just for the conversational part. Okay. In the year 2000, they released these math problems, the unsolved math problems, and within just a few years, one person solved one of the unsolvable types of math problems. And of course, like they're like, hey man, we want to give you money, we want to give you this medal, let's give you a ceremony. And he went nuts solving that one problem, and locked himself in his mother's apartment in Russia, and like hardly anybody has talked to him since. Because these problems, if you check them out, they're very difficult to solve. They're very, very advanced types of concepts in math. And this guy just whipped it out like it was nobody's problem, right? Like what I say, easy peasy lemon squeezy, right? That is just what he did. That's how he functioned. But he gave up his sanity to solve one of the century's math problems, which I find that kind of neat. That's kind of cool. Let's do another example, okay? Big bada boom. That is just what he did. That's how he functioned. Ooh. Here. Do you remember what I said with let's do another example. Hang on. Let's take a look. Big bada boom. Let's go with, I want to have you write an equation of a line that runs through. So, write an equation of a line that passes through this point of passes through the point 0, 3, and has a slope of, what do we want our slope to be? 2. Let's go with just 2. Okay. So a slope of 2 passes through the point 0, 3 and the slope of 2. Well, I want you to reference back. Let's do that. Make it a little bit neater. Our slope-intercept form. Slope-intercept Such a long word. Math people don't like that word. I mean, we love that word, but we don't like writing it. So what is our slope-intercept form? We have, let's go with a nice and kind of like this orange color. That is y equals, checking my chat out, I'm sorry that I missed you guys earlier. I hope I was still able to answer some of you. Y equals mx plus b, right? So y equals mx plus b. And then we know that it passes through this point here, 0, 3. What's special about this point? Where is it at? It is on the y-axis. We are told it is an equation of a line. We know that there is a line, it exists. So it passes through the point 0, 3, which is where, that's your intercept. That's the intercept of the line. And so 3 is your b. So b equals 3 because of that. We know it. Okay? And then slope. What is the slope? Well, m, the letter m is your slope, and that is 2. Boom. We got it. All we have to do now is just rewrite this. So y equals 2x plus 3. That is our equation of the line that passes through this. This is what describes it. And yesterday, I had my other live class. If you wanted to go through and graph this, you absolutely can, right? All you have to do, so y equals 2x plus 3. Do your little table, your x and y table, your inputs and your outputs, and you go ahead and you put in whatever inputs you want. So you can go, my favorite 3 points are -1, 0, and 1. And if we were to just do this really, really quick, 2 times a -1 is -2, plus 3 is a +1. 0 will give us 3. 1 will give us 5. Boom, we can draw this line. No problem. I always like 3 points, right? Like, all you need to define the line is 2. You only need 2 points, but 3 points just makes it a little bit nicer, right? A little bit neater. I mean, you can draw things with your straight edge, no problem. So, let's take another look at another example. We will do it just from 2 points again. That is very good practice. You get to see a lot of things. So our 2 points, I'm using the erase button. Let's change it to the whiteout. So our 2 points will be, for those listening, our 2 points will be -6, -1, and 9, -11. So our 2 points will be -6 and -1. And our second point will be 9 and -11. So I give you these 2 points, and you need to find the equation of this line, right? How do you go about doing that? If export is in here, how do you go about it? How do you solve this? Let's use our formula. Our formula is y equals, or not y, slope. First thing that you find the slope. Find slope. The way that we're going to do that is with our slope formula, and that is slope equals y2 minus y1 all over x2 minus x1. Let's put all of these things in there, all of our numbers, x2, y2, x1, y1. I like to over-label things. Keeps things, I mean, it doesn't look as neat when we're done, but it makes it a little bit easier. My brain doesn't have to store any of this information, right? So we have -11 minus, our y1 is -1, all over x2, which is 9, minus a negative 6? What is a negative 11 minus a negative 1? What is a negative 11 minus a negative 1? That is a negative 10. You add. The signs flip on you, okay? And yeah, by the way, I'm dressed up. Find the slope and use y minus y1, yep, equals m minus x. Close. I mean, I know it's a little bit difficult to give answers through the chat, especially math problems, right? You're like, oh, crud, how do I type this out? Equal sign, y's, minus signs, right? But that's okay. I export, you get an A for effort. An A for effort. 9 minus a negative 6. Well, what happens when you do your minus a negative? It turns into a positive, so 9 plus 6, and that is a positive 15. This can reduce down. What number goes into both the negative 10 and the 15? It's 5. 5 goes into both of these. It goes into it. We have a negative 2 on top, all over, a positive 3 on the bottom. So this is our slope. Boom. Easy peasy. Not too bad. We can erase all of our work just to keep it a little bit neat. Little bit neat. Oh man. I always forget that. So we have our slope. We don't need this anymore. Okay. Oops. A little bit too far. We will move this over. And oh, whoop. Nice. I exposed the graph again. Okay. So our slope is negative 2 and 3. We go ahead and we can plug this into our problem. Our y equals mx plus b. Boom. All we got to do, we have our m equals negative 2/3. Okay. Here's an easier way of going about this. Okay. Well, it's just the same. So we'll rewrite this as y equals negative 2/3 x plus b, and then go ahead and we'll plug in this first one right here. So this is our y and this is our x. So we want negative 1 where our y is, negative 2/3. And then in our x spot, we have a negative 6 plus b. Look at that. We are doing very well. So, what is a negative 2/3 times a negative 6? The negative signs cancel out. We get a positive 12/3 plus b equals negative 1. Crazy math, I know. Okay. So we have our negative 1 equals 12/3 plus b. What is 12/3? What is another way of thinking of 12/3? How many times does 3 go into 12? It is 4 times. Okay. For the sake of keeping things neat, we will go right here. So negative 1 equals, way down, bottom right side, 4 plus b. How do we get rid of this 4? How do we get rid of that 4? We subtract 4. We subtract 4 from the right side. Whatever you do to the right side of an equal sign, you must do to the left side of the equal sign. Whatever you do to one side of an equal sign, you must always do to the other side. So we will subtract 4 from this side. What is a negative 1 minus 4? Negative 1 minus 4. You have $1 of debt, and I come up to you and I tell you, and I say, hey, you watching Paul's stream, you owe me another $4. You already owe me $1, now you owe me another $4, so I get a negative $5. I'm $5 in the hole. Does it matter which x we pick between x1 or x2? So it doesn't matter, right? But as long as you maintain it throughout your entire problem, right? So if I say that this is x1, that 9 is x1, then this must be, not x1. This must be y1, okay? So don't switch those things up, but it has to maintain itself with whatever. As soon as you make a decision on which one is x1 and which one is y1, like, you have to keep those things the same. We could switch this all up, and I can do that really quick too after this problem. So we have -5 equals b, or we could just rewrite it up here. So b equals -5. Let's see. Am I still on the stream? We'll see in a second. That's good though. So we can rewrite our equation. I'll do it in blue. You guys get to see how crazy my brain is. I work downwards and upwards. I mean, I advocate for neatness in your math, and if you are a more organized person, bravo to you. I am a little bit jealous of you. But do whatever makes you feel comfortable. Do whatever works best for you with math, right? Cool, good. I'm really happy you got that export. So our equation of the line will be y equals -2/3x minus 5. And that is the answer to that problem, right? We found the equation of the line that passes through those 2 points, and that's all they gave us. They gave us 2 points, and they asked us to find the equation of the line. Boom, we got it. Done. Easy peasy, lemon squeezy. How is this stuff for everybody? And if you're just tuning in, make sure you hit the like button, please. I beg you to hit that like button, because think about how cool that is. It is spreading this information. People need help with math, frankly, and I'll say that the current state of the education system with math is terrifying. It's terrifying. I went through a time period in our education system in the United States called No Child Left Behind. Do you know what it did? It left almost an entire generation of children behind. There are tons of people, tons of millennials, tons of people that are older, tons of people that are younger, that these concepts they don't get these concepts, right? And so when you hit the like button and if you hit the subscribe button, it's going to spread this around. It's going to help other people, right? That's a cool thing. Who else? I don't know. Maybe there's a ton of other people that are who else thinks, hey, let's stream math classes online and see how successful it is, right? I don't care how successful it is. If I help out one person, which I've been helping out Export, makes it all worth it. Everything is worth it if I help out one person. But you can try to help out more people by participating, by chatting like Export, by chatting like our Alpha and our Spooky Gamer. That puts this out into the algorithm. More people will see it, and it's up to them if they decide to stick around. And I also think it would be hilarious if, for some crazy reason, someday from now, maybe a couple of months from now, I log in and I set up my stream and we have like 100 people watching me do math. That would be insane. I don't know. Part of me would be terrified. I'd be like, well, they're gonna see me mess up probably, but that's okay. I have a background in math. Everybody makes mistakes. Everyone makes mistakes in math. I don't care how good you are, you'll make a mistake, and more people should know that, and that it's okay to make mistakes in math. Okay, let's clear this out. I think I'll do one more example, and then we'll move on. We'll either move on or we'll call it good, okay? Where is my math book? Oh, Export, actually, since this will be my last example, do you have anything specific that you would like for me to go over? You're the last person to comment. You're one of my most active viewers, so do you have anything that you would like to go over? Functions, different things with slope, polynomials, equations for triangles, whatever you want. We can check it out together. Otherwise, I will do another slope equation. Oh, here. So since you're taking the GED, let me write up on the board a problem that is something that you will, another type of question that you'll find on the GED, right? So let's go through. It is, let's clear this all out, not the erase. As you can tell, I'm using my mouse. It's a lot faster. High sensitivity for when I do finally decide to play some type of first-person shooter game. Okay. There we go. Got it all cleared up. So then we want to rewrite this problem out. Functions will be cool. Okay, we can do a function. Kind of just talk a little bit about a function. I'll give you, you'll see something like this on your test. Okay, we'll talk a little bit about it. Why is my pen not working now all of a sudden? Oh, because I was trying to write with this side. Need to write with this side. So we have, let's say I give you this table, okay? I'm gonna draw a table, or try to. Okay, so we have this table, and we have our X values and our Y values, okay? And then I tell you, export, I tell you, we have 3, we have 2, we have 1, we have 0, we have 1, and we have 11. And then in the bottom, we have 2, 2, 2, 2, 2, and you guessed it, 2. And then I'll ask you, is this a function? And then I might ask you, if not, why? Okay, so I might ask you something like that. I know it's not a complex problem, right? But it requires a little bit of a different thinking. It's not just an equation to solve, right? So what would this be? Is this a function? Okay. Let's see if export can get this. Okay. So I might ask you something like that. I know it's not a complex problem, right? But and then why? Why is it not a function? Okay. I'm hanging out. We will see. So what would this be? Is this 3, 2, 1, 0, 1, 11 for our X values. Those are all ordered pairs, by the way. All ordered pairs. And then my Y value, it's all 2s straight across. Okay. So what this might look like, if you have something where your Y values are all the same, right? I'll do a very rough graph up above my head. Okay. So here's our Y-axis. And our X-axis. Okay. So we have our X-axis, our Y-axis. So if you have all of the same Y values, what does that mean? It means that you have just a horizontal line, right? That it's parallel to your X-axis. It has the same slope, right? When you talk about slope, if something is parallel, that means it has the same slope. If it's perpendicular, you have an inverse slope. Okay, but this question here is it a function, right? So is it a function? Well, the big thing to ask is imagine every one of these X values, right? Does it go to that same point, right? Can you do a vertical line test through this and have it pass? So 3 and 2, well, so here, this is why it's so kind of weird. So, okay. So remember, the vertical line test is what you want to do, right? So if I draw a vertical line, I know I'm a little bit slanted on the whole thing, but if we draw vertical lines through this, right? So I did purposefully, I tricked you a little bit. I'm sorry, export, but so these are just this is just one point. This is the exact point, but I listed it twice, right? but all of them are going to your y of 2, right? And what that means is that it's all a horizontal line, right? So that means that it passes the vertical line test. That means that it is a function. This is just the trick. That was just the trick, right? Like, it's like, hey, Paul, you wrote the same thing twice. Absolutely. I kind of did it on purpose, just to get you to pause for a second, right? And it's okay to not get it right. The other part is just to be like, okay, well, I could just visually graph it. If you have time, graph it. It will help you, right? It's a horizontal line. A horizontal line will pass your vertical line test, right? That means that you can draw vertical lines throughout it. There are no points where it crosses it twice, so you're good to go. You're rocking out with your functions out. So let's erase all of this stuff. Oh yeah, export. I was gonna ask you what. So I don't know. Are you a gamer at all or no? Do you play any games? Kind of curious. I used to be a gamer. I'm not as much anymore, but very curious if you are a gamer. Let's rewrite this problem. I'll write a problem up on the board, and we're gonna rewrite this into slope-intercept form. Minus 5. Then x minus 1. So I'm asking you to, let's make this a little bit neater. Where's my cursor? There. And then I'm asking you to write this in y-intercept form. Okay, so how do we go about doing that? How should we write this in y-intercept form? That will be -5 gets distributed through your parentheses, giving us -5x. What's a -5 times a -1? It is a +5 on the right, equals, and then we just can drop these parentheses. It doesn't really matter, right? So then we add 2 to both sides to get rid of that 2 on the right, because y-intercept form, we want it to look like y equals mx plus b. Okay. So we add 2, oh, not there. We add 2 to both sides, and we get y equals -5x plus 7. So we are in y-intercept form. We've successfully done that. But then what if I asked you the slope? The slope and the y-intercept, what are they? What is the y-intercept? What is the slope? The slope is -5. The y-intercept is 7. So I could tell you just from this that it's going to cross through 0, 7. And it has the slope of -5. So what else can I tell you? It goes down from left to right. It crosses the y-axis. That's the y-axis at the point 0, 7. It goes down from left to right. It's pretty steep with the slope of -5. It's going down from left to right, pretty steep. And that's it. That's it. Slope isn't too bad. Slope isn't too bad. Just remember, it's the steepness of a line, rise over run. Your change in vertical over your change in horizontal. Remember that delta symbol. You might never use it again, but if you do go any deeper in math, you'll see it. It will haunt you at times, right? Especially when you take Calculus 1 in college, if you go on to college, right? But otherwise, I think we can end it there. I've been going for an hour and 15 minutes. I am curious. I am indeed, but not much nowadays since GED is keeping me busy. That's awesome. That is good. That is good. That's good focus. That's what I would say. It's very good. Prioritize your GED. Learning can become a game, a very good game, like an RPG type of game, right? You're leveling up your math skills right now, and just like in World of Warcraft, you have to grind your skills out. You will be grinding out math, and sometimes you just really focus on your like leather making, your leather work, and you just want to reach level 100, and you might do that with math. You might want to reach level 100 with math. Good luck. Good luck with that. I know, I'm crazy. I'm weird. I'm a goofball. But we will call it good there for today. I will do my outro of saying I greatly appreciate you watching. We actually had quite a few people in here on and off throughout the class. If you would like to subscribe, that would be great. I would appreciate it. Otherwise, I hope you have a beautiful day. I appreciate you, and we will talk again soon. I will have another class tomorrow between 9 and 9:30. There is a little bit of leeway there.